Alright, welcome to Ms. Jorgen's here, section 9.3, solving quadratic equations. This is going to be a part 1. We're going to have a bunch of different sections on solving quadratic equations. So stay tuned and be ready for learning here. There will be a few questions for you along the way. Alright, so the first example we're going to look at is the equation x squared equals 16. If we want to solve this equation, what we're looking for is some number for x that could, if we put that number in for x, it would make the equation true. Now, what's going to be tricky about the ones we have today is if we put in the number 4 squared equals 16. But if we put in the number -4 times -4 is also going to make a positive 16 because a negative times a negative makes a positive. So that's something really tricky we're going to have to think about throughout the day is we're going to have the positive and the negative version of the answer. So my process for getting to the number 4, because if you don't think of the number 4 right away, we need some sort of process, is to take a square root of both sides. And so what I'm going to do is I'm going to take a square root of both sides. And the square root and squared on x cancels, I'm just left with x. And the square root of 16 is 4. The problem is that's only giving me the positive version of the answer, right? And so my rule is that when I take a square root of both sides of the equation, on the side with the number I put plus or minus. And that shows that I can either have the positive or the negative version of that 4, right? So my answer is going to be x equals plus or minus positive or negative 4, all right? So that kind of takes us through kind of the most basic example where you're just looking at x squared equals some number. Go ahead and try a different version of that problem. I'm going to give you x squared equals 9. So go ahead and work that one out and enter your answer when you're ready. So square root of both sides. When I put the square root of both sides, I'm putting the plus or minus in there. X squared equals plus or minus square root of 9. 9 is 3 times 3, so positive or negative 3. And so square root and squared cancel, and I'm left with x equals positive or negative 3 as my answer there. Hopefully that's what you selected. All right, we're looking at example 2 now here. 3x squared minus 27 equals 0. Now, when we're solving equations with a couple different steps, we've always had the same procedure throughout the year in this class. We're always going to undo PEMDAS in reverse, right? So I have my minus 27, which is stuck by subtraction, right? I have my multiply by 3, which is stuck by multiplying, and I have my x squared, which is the exponent, right? So I'm going to start by undoing my adding and subtracting that 27. Then I'm going to undo my multiplying the 3. Then I'm going to undo my squared by taking a square root. So that's kind of my process here. And I'm always going to kind of set that up so I know what order to go in. The most important thing is kind of knowing the order, because once you know the order, we should just be able to undo the operations with their inverse. So I can undo a subtract 27 by adding 27 to both sides. And I get 3x squared equals 27. Then I can undo the multiply 3 by dividing 3 to both sides. I get x squared equals 9. And so that takes care of my adding and subtracting, then my multiplying and dividing. Then I'm just left with taking a square root of both sides. And I got to make sure when I take a square root of both sides that I add that plus or minus. So square root and squared are inverses, so I'm just left with x. And I get positive or negative, and then the square root of 9 is 3. So my answers would be positive and negative 3. Right? So that kind of takes us through our first example here. All right, we're going to go ahead and try another one here. X squared minus 10 equals negative 10. And so in this case, I just have two numbers. So when I set up my levels of PEMDAS, I just have that minus 10, which is to subtract 10. And then I have my x squared, which is an exponent. So I'll start by undoing my subtract 10, and then I'll undo my squared. So I can undo subtract 10 by adding 10 to both sides. And I'm left with x squared equals 0. And then I can go ahead and take a square root of both sides, putting plus or minus, and I get x equals positive or negative 0. Now, we have to be careful about in this case is positive 0, negative 0. 0 doesn't really have any sort of sign to it, right? 0 is not positive or negative. It's not like 1 where you could have a positive 1 and a negative 1, or 2 where you have a positive 2 and a negative 2. 0 is just 0, right? And so for 0, I actually wouldn't put positive and negative 0. I would just have one answer of 0, right? It's not like I could be here or here. 0 is just one spot, and it doesn't have a positive or negative associated with it. So if you get 0, you're just going to put 0 as your answer. Another case here is if we have something like negative 5x squared plus 11 equals 16. And this is kind of the tricky case here. So I'm trying to I'm trying to get my x by itself. So in terms of PEMDAS, I'm trying to move my add 11, I'm trying to move my multiply by negative 5, and my exponent, which is squared, right? So I'm going to start by moving that add 11 by subtracting it. And I get negative 5x squared equals 16 minus 11 is 5. And then I'm going to divide by negative 5 to both sides. And negative 5 divided by negative 5 is just 1x squared. 5 divided by negative 5 is negative 1. So I get x squared equals negative 1. Now the problem is when I have a square root of a number like negative 1, because I'm going to go ahead and square root both sides, and when I do that, I end up with just x on the left and the square root of negative 1 on the right. The problem is that the square root of negative 1, I'm looking for some number that multiplied by itself to make negative 1. And if I pick 1, 1 times 1 is positive 1, not negative 1. If I pick negative 1, it's also positive 1, not negative 1. So I cannot take the square root of negative 1. I can't take the square root of a negative. So anytime you have to take the square root of a negative when you're working out these problems, you're going to have what we call no solution. And that's because it's impossible to take the square root of a negative number. So since it's possible to take the square root of a negative number, there's no possible x value that could work, so we say that there's no solution. All right, we're going to have you try a couple here now in a row. First one is going to be 2x squared minus 32 equals 0. So go ahead and try that one. You're going to solve it for x and enter your answer when you're ready. All right, so working that out, I moved my 32 first by adding it to the other side. Then I divided by 2. 32 divided by 2 makes 16. When I take the square root of both sides, I got to remember to put that plus or minus on the square root of 16. And then the square root of 16 is 4, right? So hopefully you put plus or minus 4 on this one. So that's the first you try. Second one for you to try here, you're going to try x squared minus 8 equals negative 8. So go ahead and try that one and enter your answer when you're ready. Alright, so working that one, we add 8 and we get x squared equals 0. Take the square root of both sides. Of course, same thing as the last time. If we ever have plus or minus 0, there's only one option for that. It's just regular 0, right? We don't have positive or negative associated with that number. So we just left with x equals 0. All right, third you try before we try another example. Go ahead and try negative 2x squared plus 3 equals 27. Go ahead and try that one and enter your answer when you're ready. All right, so working that out, I subtract 3 and I get 24. Then I divide by negative 2 and I get x squared equals negative 12. The problem is now when I go to take a square root of both sides, I'm ended up with the square root of negative 12. And I can never have the square root of negative 12, right? Because the square root of a negative is never going to come out. A positive times a positive will equal a positive, negative times a negative will equal positive. So I can never take the square root of a negative. So I'm left with no solution here, similar to our last example 4. All right, so those were our kind of U tries. We have one last example to kind of go through here, and hopefully you kind of got the basics down based on this U try. All right, so we're going to solve a different kind of question now, because if you notice, every time we did our levels here, we always left the parentheses level empty, right, for the first couple of problems. So we can have some problems with parentheses in play. And the way that it would work if parentheses are in play is I'm going to have to, if I look at this left-hand side of the equation, I'm going to have to move my 1 and I'm going to have to move my 2, right? Well, the 2 is an exponent. It's the x squared part, right? And then my 1 is subtraction, so you might be tempted to put it down here. But the problem is it's subtraction inside parentheses. So since it's subtraction inside parentheses, the kind of last trick we need to know from this last example is that that minus 1 is going to go in the parentheses level. And the reason why that matters is it depends on what order we go in, right? If the 1 was in the subtraction level, I would undo it first, right? Because it'd be down here. But since it's up here, I'm actually going to undo the exponent first by taking a square root, right? And so that's going to just make the process look different because of the order that I go in, right? So I'm actually going to start by taking a square root of both sides. Equals plus or minus square root of 25. And when I do that, the square root and squared cancels. I'm left with x minus 1 on the left. And then I'm left with plus or minus 5 on the right. The tricky thing is now I'm going to want to add 1 to both sides, but I have to be really careful because adding 1 to 5 is going to make it go up to 6, but adding 1 to negative 5 is going to make it go up to negative 4. And so I think the most helpful way to do this is to kind of split it into two parts and say I have two different equations here. I have x minus 1 equals positive 5, and I have x minus 1 equals negative 5. And then I can solve out those two mini equations by adding the 1. So in the first one, adding the 1 to both sides, I'm left with x equals 6. The second one, adding the 1 to both sides, and I'm left with x equals negative 4. So my two answers here would be x equals 6 and x equals negative 4. All right, let's go ahead and try one more of those just to make sure everybody's on the same page here. Again, I'm going to have undoing PEMDAS backwards. My subtract 3 is inside parentheses, and then I have my x squared. So I can undo my x squared first by taking a square root, and then I'll just be left with x minus 3 on the left. And again, I have to put positive or negative every time I take a square root, right? So square root of 16 is 4, so I have positive or negative 4. And I think the kind of step we need to remember is that we cannot just then add 3. We have to kind of show both the possibilities here. Either x minus 3 is 4 or x minus 3 is negative 4, and then we can go ahead and solve them out. So from that step, go ahead and find the two values from x that will work here, and then you can enter your answer when you're ready. All right, so adding that out, we get 7 and negative 1, so that should be your answer on this one. All right, thanks for following along. I know that was a few more examples than usual. You should be set up and ready to try the big ideas practice now. Let me know if you have any questions.